In this example problem, it states, in the lab, a scientist found a bottle of sulfuric acid where the concentration label had been removed. They used 27.3 mils of a 1.35 molar sodium hydroxide solution to neutralize a 65.0 mil sample of sulfuric acid. What is the concentration of the acid in molar? Now, in this case, we are able to think or realize that this is going to be a titration. And so a titration is the ability to balance the acidic and the basic units. So we need to have a balanced equation. Alternatively, you can figure out the ratio of base to acid. But for sulfuric acid, which is one of the ones you need to memorize, the chemical formula is H2SO4, and sodium hydroxide is NaOH. So H2SO4 plus NaOH, and that's going to give us salt. So in that case, Na2SO4 plus H2O. So an acid and a base, when they come together, always give you a salt, which is basically an ionic compound, and water. This doesn't need to have states. So from here, we're going to balance this equation. So we see one sulfate on both sides. We see two sodium, so we'll put 2 here. And if you calculate your protons, you're going to need this here. So now, a titration reaction really only has 3 steps. Step 1, determine moles of the known. And we're going to do that by using the volume and the molarity. So I'm going to take my 0.0273 liters of sodium hydroxide and multiply that by the concentration of 1.35 moles in 1 liter. And that gives us 0.36855 moles of NaOH. Step 2 is to determine moles of unknown. So now I'm going to use my balanced equation, and I'm going to say that there are 2 moles of NaOH for every 1 mole of sulfuric acid. And so when we plug that into our calculator, we determine that there are 0.018428 moles of sulfuric acid in, it turns out it tells us right here in the problem, 0.065 liters, so 0.0650 liters, so we just divided by 1,000. When you plug that in your calculator, you should get a 0.284 molar H2SO4. You'll notice that I did not use the M1V1 equals M2V2 equation. That is unlikely to get you the right answer.